Okay, so as I showed you, in the module is the PDF copy of this first chapter. Once we get the WebAssign login, you'll have access to the ebook. But for now, if you want to read through the lesson other than just the notes that I provide, you can always look for that PDF file. Now, as I showed you when I went through Canvas, we're starting with section 2. However, you should be aware of the content in section 1. So if you want to read through it on your own, you can do that. I'm not going to give you specific quiz or test questions from section 1, but just read through it so you do have that background knowledge. So go ahead and take a look at what an integer exponent is. So when you have an integer exponent, that exponent or power tells you about the repeated multiplication. So for example, if I have a number or a variable that I see a whole bunch of, and I don't want to have to write down A, I can write that in exponential form by counting how many A's I have, and that would be written as a to the 5th power. I can do the same thing if it's a number. I can count however many -4's I have, and then that becomes the power. Now notice these -4's are in parentheses, so it's going to be very important that you include the parentheses if it has it. Because there is a difference, and we're going to see this coming up, when I evaluate -4 to the 3rd, and then if the -4 is in parentheses. It will change. Okay. So, just this, I'm going to talk about this coming up in a minute, but just be aware of it's important whether it has parentheses or not. So, same thing here, 2x, 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 there's 4 of them, so that's why the power that you'll put on that 2x is a 4. So let's go ahead and look at, again, exponential notation. So if a is a real number and n is a positive integer, then a to the n power just means that we would write a n times, however many, whatever number n is. So where n is the exponent and a is the base. And again, this could be read as a to the power of n or a to the nth power. Okay, very good on this one. So the big number here is the base and the little number is the exponent. Next, talk about when we multiply exponential expressions. So when the base is the same, we're going to take the exponents and add them. So in this first example, notice the base is the letter A. The exponents are the letters M and N. So when the bases are exactly the same, all we need to do is take the exponents and add them. I do not multiply the bases. So for example, if I had 2 to the 2nd or 2 to the 3rd power times 2 to the 4th power, I would not do 2 times 2. I leave the base the same. I'm going to add the exponents, and then this would give me 2 to the 7th power. Now, if it asks you to leave your answer in exponential form, then I would leave it like that. If the question says to evaluate 2 to the 7th, then I'd actually have to figure out what 2 times 2 times 2 times 2 times 2 times 2 is. And when I evaluate exponents, you could either take them to, take 2 times 2 is 4, times 2 is 8, like that. Or if you'd rather take them maybe 2 at a time, and then just drop this one down, and then 2 at a time again, and then maybe this one, and then now finally multiply 16 times 8 and get 128. Now, if you'd rather do 2 times 2 is 4, and then times the 2 again, you can do it that way as well. Does that make sense? So however you evaluate the exponents, it doesn't really matter. Try the next one. Now we're going to practice simplifying the expressions. Now, these are all multiplication. Notice that these multiplication problems do not have an X as the time sign. The X's here in all of these examples that have an X are the variables. So when we want to show something being multiplied, we're either going to use this dot in between, or we'll just write them separated with 2 parentheses. And that indicates that we're going to be multiplying here. So again, our rules for multiplication of exponents when the bases are the same, I'm going to take the power and I'm going to add them, or the exponent. I leave the base the same. So this becomes b to the 7 plus 4 power, and it becomes b to the 11th. I don't know the value of b, so I just leave my answer like that. Now, in lesson 1 in our book, they talk about coefficients. Coefficients are the numbers that are in front of a variable. So when I'm going to be multiplying these expressions, I'm going to multiply the coefficients. So I'm going to multiply 3 times 4. But then my variables have exponents. The variable base in this problem is the same. They both have an X. So then I just have to add 2 plus 3, and it becomes x to the 5th. The next one, I'm going to do the same thing. I'm going to multiply the coefficients. Negative 3 times 4 is negative 12. And then the powers on those x's, those exponents, I'm going to add them. So 2 plus 4, and I get 6. Same thing on the next one. I'm going to look for variables that have the same base. So first let me do the coefficients. So negative 3 times positive 5 is negative 15. Next I'm going to look at my variable that has the letter a. Now if a variable does not have an exponent, I can assume this one over here by the 5a, b to the 4th. This a has an exponent of 1. A 1 is assumed there. So in order to find the new exponent on the variable a, I'm going to add 3 plus 1, and this becomes a to the 4th. And then I'm going to go back and do the same thing with the b's. The bases are the same, so I'll add 2 plus 4, and I get 6. Going to do the same thing on example E here. Notice there are no coefficients, so I'm only going to be looking at my base m and my base n. So for the m, again, remember I can assume that there is a little 1 here. So 2 plus 1 gives me m to the 3rd. And then I'll do the same thing for the n. I can assume a little 1 here. And 1 plus 4 is 5. For f, I'm back to having some coefficients. So again, remember you're going to multiply the coefficients. So 3 times 4 gives me 12. I now can add the y exponents. So 3 plus 4 is 7. And then I'll do the same thing for the z. Again, remember this z doesn't have a number. I assume it's got a 1. And it becomes z to the 3rd. Go ahead and try some more. Now these we're only taking 2 at a time, but even if you have 3 different terms here, the process is still the same. Now this very first term, I can assume that this negative sign is really like an assumed negative 1 here. So I'm going to add negative 1, positive 3, negative 2. Here's your rules for integers. Negative times a negative is a positive. So once I multiply all this, -1 times 3 is -3, and then -3 times -2 is +6. Then I'm going to go back, get all my x. And again, this one assumes got a 1 here. So 2 plus 1 plus 3 gives me 6. Do the same thing for the y's. 3 plus 2 plus the assumed 1, and it's y to the 6th. Next one, same thing. Multiply those coefficients. This last term, I can assume that this is really a -1 here. So 5 times -3 is -15, times -1 is +15. Now I'm going to go back and look for any A's. I always like to write my answer in alphabetical order. Again, it doesn't matter if you put the B first or the A, but I like alphabetical order. So this first term doesn't have any A's, but this one does, and this one. So 2 plus 3 is 5. And then I'll go back and get the B's. 4, assume a 1, and then nothing in the last one, so B to the 5th. Now, another thing you can always do, if you're multiplying a bunch of integers, a shortcut way to determine if your final answer is going to be positive or negative, if you have an even number of negative signs, your answer is always positive. If you have an odd number of negative signs, it would make the answer negative. All right, next. Again, we're still simplifying the expression. Now, have you guys heard of PEMDAS before? Order of operations. All right, so whenever you do order of operations, you always need to follow PEMDAS. So same thing here. So I need to first take care of this term and figure out what -x to the second power is. -x to the second power means I could take that -x, write it 2 times, and now I know a negative times a negative is a positive, so this becomes positive x squared, and then now this one didn't need to do anything with it, and now I can multiply these two. I can assume that this is a -1 here, and this has a +1. So negative times positive would give me -1, and then now I add the exponents. Now, you don't need to show the -1 in your final answer. You would just write it as -x to the 4th. For part B, I'm going to do the same thing here. I'm going to evaluate this first. -x times -x times -x gives me -x to the 3rd. So, bottom line, instead of having to write this out like this, if this number is an odd number, then you know the answer will be negative. If this is an even number, then it's going to end up being positive. Even meaning 2, 4, 6, 8. Odd meaning 1, 3, 5, 7, things like that. Okay, so then that term was evaluated. So now I'll bring this one down. And now I can multiply these. Negative times negative becomes a positive x, and then I add the 2 exponents. Key thing to remember is, what do we do with those powers on those variables? And when we multiply, we add. The only thing we're multiplying are coefficients. Let's try some more examples. More simplify the expression. So this time it's the same thing. We're just going to do the left side of the equal sign, the plus sign, and then the right. Once we get the answers, if they're like terms, then we'll add them. If they are not like terms, we can't combine them. So we'll do the left side here first. We'll multiply the coefficient. So 5 times 2 is 10. x squared times x cubed is x to the fifth. We add those powers. And then I'm going to do the right side of the plus sign. 3 times 4 is 12. Again, remember, assume the little 1 here. X to the fifth. Now, if you remember back from your Algebra 1 days, these are like terms. They can be combined. When you add like terms, we do not add exponents. We only add coefficients. So I'm only going to add 10 plus 12, and I get 22 x to the fifth. Now, let's say instead the answer we got here, let's just pretend that it was x to the fifth plus 12x to the fourth. Let's say this power was different from this one. If that's the case, then you would stop and that would be your answer. The only time you can combine terms is when they're identical. So it would have to have the exact same variable with the exact same exponent in order to add the coefficients. Pretty good on that? All right, let's try the next one. We're going to do the same thing. We're going to simplify this side and then this side. And then if they turn into be like terms, we will subtract them. So once I simplify the red that I underlined, 3 times 5 is 15. I'll add the exponents on the a's. Do the same thing for the blue. Multiply. And again, I can assume a 1 here. So this should become 6a to the 8th. Notice the variables here in these terms are exactly the same. So now I can just subtract the coefficients. 15 minus 6 is 9a to the 8th. Again, if that were a different exponent, let's say it was a to the 7th, then I would not have been able to combine them. So this was all multiplying two expressions. Now we're going to see when we raise a power to a power. Pretty good on this slide? Here we go. So raising a power to a power. So notice I've got a to the m is a power, but then it's raised to another power, which is the m. When you raise a power to a power, we're going to multiply the exponents. So here, a to the m raised to the n power, we just take the m and the n and multiply them. Okay, it could also be written this way or this way. So they've done the first example here. X to the fourth raised to the fifth. You take the powers of 4 and 5 and you multiply them. So if I have x squared raised to the third power, I would just turn this into x to the 2 times 3 power, which is 6. So power to a power, we multiply. Now, before we continue, I want to talk about raising something to the 0 power. So let me just add a little blank page here. So one fact that you should have memorized back from Algebra 1 is that any number raised to the 0 power equals 1. Even if I have 1,000 and I raise it to the 0 power, it equals 1. Now, here's where it gets a little tricky when we have negative integers that we raise to a 0 power. So if the base is positive, no problem. The answer is 1. But if I have a negative number, let's say it's negative 1, and if it's in parentheses and I raise it to the 0, it's 1. But if there's no parentheses around it, this will simplify to negative 1. Because what's happening here is this 0 power is only on the 1. It's not on the negative sign. So really what we're assuming here is this you can either think of this as falling down and then you get -1. Or think of turning this negative sign into a -1 and then writing this as a 1. And you can write it that way as well. So let me just show you with the variable as well. -a, if it's in a parentheses, it's 1. If there's no parentheses, really what this means is this comes down as a -1. This evaluates to a 1, and -1 times +1 is -1. So if there is no parentheses holding that negative sign next to the number or the variable, then your answer is going to be negative. So just to show you the 3 scenarios, if I have a positive number raised to the 0 power, it's 1. Even if I have that positive number in parentheses, it's still 1. But as soon as I have the negative number, no parentheses, then it's -1. But if it holds it in there, sorry, and I need to put the 0 outside, then this one simplifies to a +1. So just be careful on questions like these. And we'll do some more. All right, now on to the simplifying the expressions. Next slide. Everybody good here? So here we go with the power to the power. Now, again, remember this variable x, I can assume has a power of 1. Now, this 3 exponent here is going to need to go to the 2 and to the x. Because really what this means is 2x times 2x times 2x. And then 2 times 2 is 4, times 2 is 8. And then I can add these exponents, and it's to the 3rd. Or think of it as 2 to the 3rd, distribute the power to the 2, and then distribute it to the variable, which becomes power to the power 1 times 3. So, and then it turns in like this. Yes?
So would you have to simplify the 2 to the 3rd times the x to the 3rd?
Yeah, so most of the time when we quiz, I'm going to expect you to figure out what 2 to the 3rd is. Yeah, don't leave it in exponential form. So anytime the question says simplify, then it's going to expect you to figure out what that number to that power is. That's a good question. All right, let's try the next one. Again, this 2 exponent needs to go to this 2 base as well as to the x to the 5th. So this really is going to become 2 squared and then x to the 5 times 2 power, because it's a power to a power. And then this gives me 4 x to the 10th. Now again, if you'd rather write it as 2x to the 5th times 2x to the 5th, and then you could multiply the coefficients and then add the powers. Either way. Next one, be very careful here with negative numbers. This -2 is in the parentheses. So really what we're doing here is -2 times -2, which is going to give me +4. So again, if you'd rather rewrite it as 2x to the 5th times 2x to the 5th, multiply the coefficients, negative times negative is positive, and then add the powers on the x. Or just remember, the 2 goes to the -2, and it's in a parenthesis, so -2 times -2 is +4, and then power to the power multiply. Now, here, the negative sign on part D here is in parentheses, but notice my exponent is odd. So when this power is an odd number, and you're putting it on a negative number, Negative 2 times negative 2 is positive 4, but then times another negative 2 gives me negative 8. And then power to the power, multiply, and I get a 12. Next one. This power of 3 goes to the negative 3. It's going to go to the x and to the y. So for the first one, negative 3 to the third power. Negative 3 times negative 3 is positive 9. Times another negative 3 gives me negative 27. And then for the next part, to the x, 2 times 3 is 6. And then finally to the y, 5 times 3 is 15. Now, next one was a typo. Really, this one's already simplified. But let's go ahead and put a square on it. So let's just add a little number there. So this really becomes negative x y squared if you want to write it 2 times, but you don't. So negative times negative becomes positive, and then y squared times y squared is y to the 4th. The way it was written, it was already simplified, and you would just rewrite the problem. Good there? All right, a few more. So again, we're going to follow order of operations. We're going to simplify this one first, then simplify this one, then we'll go back and multiply. So again, this power of 3 needs to go to the 3, to the a, and to the b. So 3 to the third power is 27. A squared raised to the third power becomes a to the 6th. And then b to the first raised to the third power is b to the 3rd. Next, I'll do 2 squared, which is 4. The 2 goes to the a cubed, and then to the b. And again, power to the power, we multiply. Now, notice the dot in between. Remember, when you multiply, I don't need like terms. So I can actually multiply this. So I'm going to multiply the coefficients. 27 times 4 is 108. Then I'll go back. I'm multiplying here, so I'm going to add the powers on the a's. This becomes a to the 12th. And then I'll add the powers on the b's. B to the 5th. And I'm done. No.
Write down 27 a 6 or a to the 6 b to the 3rd times 4 times a to the 6 b to the 3rd.
Yeah. You don't have to color code like I've been doing in the notes. If it helps you to do this when you're doing your homework, you can. But again, a lot of this I realize I would want to see the step like he said. I want to see the 27 a to the 6 b to the 3rd times 4 a to the 6 b squared. And then the final answer. But again, I don't need to see all the colors and how you're distributing. I'm just trying to demonstrate that just for the teaching purposes. Everybody good there? All right, let's try B. Again, the 4 is going to go to the 2. So 2 to the 4th power is 16. When I put it on the x squared, it becomes x to the 8th, y to the 12th. Same thing here. This, I can assume it's a negative 1 here. So this becomes positive x squared, y to the 4th. Again, I'm going to multiply. I can assume the 1 there. So 16, x to the 10th, y to the 16th. The next one is an addition problem. So again, I'm going to simplify each side, following order of operations. So this first term becomes 8x cubed. Then this one, the 2 is going to go to the x and the y. So x squared, y squared. Then this one, I'm just going to combine my like terms here. This is assumed to be a negative 1. So this becomes negative 4 x to the 5th y squared. I'm now going to multiply this. X to the 5th y squared. These are like terms. I can combine them. And that's my final answer. Okay, and then the very last slide. Now, if it helps you, you could also think of this as 3x over 2y, 3x over 2y, 3x over 2y. And then I could multiply it as it is, or just think of distributing this 3 to the x, to the 2, and to the y. So once I multiply all the 3's, 3 times 3 times 3 is 27. Add up those exponents. 1 plus 1 plus 1 is 3. 2 times 2 times 2 is 8. Y to the 3rd. And here we go again with these negative numbers raised to a power. When I do not have parentheses around a number, I can think of this as becoming negative 1 times 4 squared, which becomes negative 1 times 16, which is negative 16. Over here, this really becomes negative 4 to the 3rd, which is really negative 1 times 4 times 4 times 4, which is going to end up giving me negative 64. Now, when there's a parentheses holding in that negative, it's really, part D is saying negative 4 times negative 4, which gives you positive 16. And then the last one, any number raised to the 0 power is going to be 1, unless it's negative. For example, without a parentheses, this would be negative 1. But if the negative 4 is surrounded in parentheses, this answer is positive 1. So that is it for the notes on your very first section. Homework is the PDF posted on Canvas.